Since we know about series combinations, now it's time to look at parallel combinations, and since we've already done this with capacitors, it should be relatively easy to make the switch to resistors. So with capacitors, remember that the voltages in parallel are always the same. Whatever voltage is on one has to be on two, and the charges have to add up. If I have charge that comes out of the battery, it has to be split between C1 and C2. Well, same thing that happened with series is now when we put in resistors, instead of talking about charge, we're going to talk about currents. So the current that comes out of the battery must be split between R1 and R2 before it comes back together again and goes back to the battery. Let's walk through this. Let's say I have a 1 kilo ohm resistor up top and a 4 kilo ohm resistor on the bottom, and I hook it to a 24 volt battery. Looking at the addition of currents, I can take that and replace it with V equals IR, or I equals V over R. Noticing that V's are all constant here, I can make that 1 over R1 plus 1 over R2 equals 1 over R total. In other words, I add the reciprocals when I have resistors in parallel to find the total equivalent resistance of that circuit. So, doing that in this case, I have 1 over 1 plus 1 over 4 gives me 5 over 4, so it's 4/5 of a kilo ohm. A kilo is 1,000, so 4/5 of 1,000 is 800 ohms. So I can replace this guy with essentially just an 800 ohm resistor. Now I can do the V equals IR for the whole circuit. In other words, I can figure out how much current comes out of that battery if it's hooked up to an 800 ohm resistor. And in this case, 24 volts going over 800 ohms is going to give me 30 milliamps. And now we break it back apart again to figure out how much of that current goes to each of the two resistors that I really truly have. So I've got a 1 kilo ohm resistor and a 4 kilo ohm resistor, both of which have 24 volts on them. Remember, on the left side of the screen, V1 equals V2 in parallel. So I take that 30 milliamps and I do V equals IR on each resistor by itself, or I equals V over R. So when I get the current to that point right there, it's going to have to split. Part of it will go to the 4 kilo ohm resistor and part to the 1 kilo ohm resistor. I figure that out using I equals V over R. There's 6 milliamps that's going to go off to the 4 kilo ohm resistor, and there's 24 milliamps that's going to go off to the 1 kilo ohm resistor. So the current splits, and I get more going through the lower resistance. This should make sense to you that if I have two resistors and one of them is smaller than the other, more current will flow through the smaller resistor because it's an easier path, if you will. Now, doing complex combinations of parallel and series is going to be an easy next step since we've already done it with capacitors. So we're just going to keep to these rules that if I have two resistors in series with each other, I add the resistances, and if I have them in parallel with each other, I add the reciprocals of the resistances.